Now, seafood safety continues to be an extremely important issue to the producers and the consuming public of Gulf seafood. Bob.
Well, Ed, you've been involved in oil spills and oil accidents and things for decades. And I think before we get into talking about on set here about seafood safety and about what we have to be concerned about, I think we need to know a little bit more about what's out there now. We know there was crude oil. What's happened to that crude oil? What's it turned into, and what are we dealing with?
Well, crude oil starts off as many thousands of different compounds that are blended together that form the product that we know as oil. When it goes in the environment, it starts changing in composition. The small molecules, the more volatile molecules, will evaporate. They'll dissolve into the water column. These are the most dangerous components in oil. So that leaves behind kind of a gunky, oily residue that floats around. Again, it continues to undergo change by bacteria, by the action of the sunlight, the photooxidation. Some of it dissolves into sediments, and as it gets near coastal areas and can absorb on the sediments and sink to the bottom, which is what we've got here. These tar balls don't float around. If the tar balls are offshore, typically they are buoyant and they're floating around. So the oil undergoes this compositional change, which in general makes it a lot less dangerous. So the longer it can stay in the environment before coming ashore where it causes most of the damage, the better. Now, of course, while it's offshore, it's causing damage to offshore marine environments, particularly those little critters that live right at the surface. But the biological density offshore relative to the biological density in coastal marshes is much, much less. I mean, by a factor of 100 or so, you have more critters living in the marsh and in near coastal environments than you have way offshore. Any offshore fisherman tells you that. He goes out there and fishes all day and is lucky to catch a tuna or two. Whereas if you go into the coastal marshes, you catch your limit of fish almost immediately within an hour or two. That's biological density. So what we don't want is a lot of oil coming ashore in coastal marshes and can have an impact. So oil offshore is better than oil near shore if you got to have oil at all.
Yeah. Well, I think the public's gotten sort of a course in Petrochemical 101 over the last few months. But what are these polycyclic aromatic hydrocarbons? Easier to call them PAHs. Tell us what they are and why people are so concerned about them.
Well, oil has many thousands of different compounds, but there's a class of compounds in oils that chemists say they're partially oxidized. They're called aromatic compounds. And these compounds have a special reactivity when they get in living systems. There are enzymes in our bodies and in the bodies of finfish and most marine organisms that recognize these compounds as being foreign. They're not originally there. And so they try to metabolize them so that they can be excreted. Sometimes this metabolitic process will make a more dangerous form of those aromatic compounds, which could attack the genetic material and either kill cells or mutate the cells. Cell mutation is very bad because that leads to cancer. So these are the types of compounds that have the most toxic effect in oil, the polycyclics. So almost all concern associated with oil is associated with the aromatics, including the one-ring aromatic benzene and its relatives, and the polycyclic aromatic compounds. Those are the ones that we're worried about in terms of consumption of any kind of food, even for the animals that are in the environment. They can cause, just as they could cause problems for us if we consume it, they cause problems for the animals that live in the environment.
Yeah. We often hear that these PAHs are carcinogenic in humans. Would you care to comment on that?
Well, PAHs are a very broad class of compounds. There are certain of those PAHs that are ability to form cancer, and they're known to do it in people. Out of the thousands and hundreds of thousands of compounds, only a very small number are known to cause cancer in people. And there are one or two PAHs that are known to cause cancer in people. They're not a strong cancer-causing potential, but they do have that mild potential to cause cancer. So we certainly don't want to do it. By the way, those PAHs are in a lot of things around us. When we charbroil our steak, we're making PAHs, right? Soot from fires have PAHs in it. There's any number of areas in our environment. PAHs are fairly ubiquitous in the environment. We just don't want elevated levels in anything we consume. The good news is about PAHs, though, that they are fairly easy to metabolize and they do not build up in the edible tissue of thin fish and shrimp and crabs. They can accumulate in filter feeders like oysters and clams, because the oil would accumulate in the gut of those and we consume the whole organism. But we don't consume the whole organism with shrimp, crabs, or a larger species.
Right. Well, and I know one thing that really concerns scientists when they read something in the media or other sources where someone simply reports that we did a study and there are PAHs there. We did a study and there are hydrocarbons there. It really is meaningless to the reader, isn't it?
Absolutely. We have a saying, if you don't find PAHs in an environmental sample, you haven't done the analysis right. PAHs are ubiquitous around the world, and they're made in forest fires. They're not all from oil. They're made in combustion processes. The PAHs are in coal, any kind of fossil fuel. So they're widely distributed in the environment. Now, elevated levels of PAHs in foodstuffs can cause problems in humans. That's why it's certainly tobacco smoke is another example where you have polycyclic, because that's a combustion process. We don't want to be ingesting those things. We shouldn't charbroil our food. We shouldn't try to drive behind a bus that's setting out a bunch of diesel soot, because pH is in diesel soot. So we're exposed to those, and virtually all the time our exposures lead to no danger. Yeah. Very, very small percent, a tenth or a thousandth or a millionth of a percent, that can cause problems. Yeah. Right? Just like all smokers don't catch cancer.
Sure.
But some of them have a greater tendency to develop cancer from exposure to the polycyclics in tobacco smoke.
Right. So it's really good for communication if people understand that PAHs have been linked to disorders that are unfavorable to us. But if somebody reports that they are present, right, they should ask the question, what are we talking about? Give us some context. How does it work? Why should we be concerned about it?
Right. For instance, PAHs don't accumulate in edible tissue. But if I take a salmon and I smoke that, well, smoke has PAHs in it. So you have, in smoked foods, as an example, you have much higher levels of PAHs than you would when trying to consume. PAHs simply don't bioaccumulate in the edible portion of food that we eat because of our enzyme systems in our bodies and in those animals. It doesn't accumulate such that it. But we can do something to that food. We can burn it, or we can smoke it, and that puts PAHs, and then we consume them. A lot of people eat barbecued food and charbroiled steaks for a long time. They don't get cancer. So getting cancer is a very improbable event. Unfortunately, it does happen. PAHs are one of the compounds. The PAHs in this crude oil from the Mikado well are not the strong cancer-causing potential that some PAHs are. I mean, we're talking about a big family, and some of them have a much higher potential for causing cancer than others. The good news about the PAHs in the oil is that there's very low cancer-causing potential in the naphthalines and the phenanthrines, the 1- and 2-ring polycyclic aromatics.
Yeah. But we still should be concerned about them and keeping an eye on them, but we should always ask those questions for clarification.
Absolutely.
Very well said, yeah. Well, let's continue on this. Tell us why we use the dispersants. Why were the dispersants originally used?
Well, dispersant is pure and simple a soap for oil, right? So we've got oil floating on the surface, and sooner or later that oil is going to come ashore. Right? Now, when it's offshore, well offshore, and it's floating around, it's already caused damage to the environment. Those animals that live there have been zapped by the fact that the oil came to and interfered with their habitat. But what we don't want is that oil to move onshore, particularly to marshy habitats that serve as the basis of the food chain in the northern Gulf of Mexico. For what, 90-something% of all of the animals, the parts of the food chain start down in their root structures. So we don't want that oil to come ashore and cause much more massive damage than it already has offshore. So the decision is made to spray them with a soap. The soap with wind energy causes the oil to break apart and form really, really tiny little droplets that dissolve down in the water column. Now, when it dissolves in the water column, it's not going to come ashore as a big glob and cover things. Remember, the oil went in the environment. It had toxic components. Most of those toxic components have been weathered away. So it's a sticky material, and it can cover it. It can come ashore and cover the grass and cause that to die away. It can get mixed down into the root structures, cause damage down there. So we would like to keep that from happening. You wash it off the environment. You're literally washing it off by spraying with the dispersants. They cause the oil to break down into tiny droplets. Those droplets dissolve into the water column and are much more degradable by bacteria. The little droplets are easier for the bacteria to degrade than a big glob. So the whole idea of dispersants is you accept damage by dispersing the oil offshore to keep greater damage than coming onshore. It is literally the lesser of two evils. And most people think that it's lesser to dissolve the oil into the water column. And you're allowing exposure, by the way. It's floating on the surface. Little animals right at the surface, if they've been zapped. But when you disperse it down into the water column, of course, animals that are swimming in the water column are getting exposed. Good news is that most fish will recognize that they are in oilier water. It doesn't taste good. Turn around and go the other way. If you have structures offshore where you have barnacles and things that can't move, they're stuck there, and dispersed oil comes over them, and they get exposed to that oil, and it does cause damage.
Right. Well, you know, when they first started using core exit and everybody started learning that term,
right.
Everybody was concerned, and the mantra was that this stuff was very toxic, and it wasn't even able to be used in most countries of the world. Couldn't be used in shallow water, couldn't be used in deep water. What does that mean to us in our commercial fisheries? Since the gusher, we have had plenty of time to talk about and to study these breakdown components of core exit. Why should we be concerned about it now, and should we be concerned when we think about seafood safety?
Right. Well, back in the late 60s, mid-60s, when super tankers first started moving oil around the world, when our appetite for oil really grew, there were several oil spills, and the dispersants that were used at that time were very dangerous to the environment. And in fact, use of the dispersants probably caused more damage than the oil. We've got a new generation, several new generations since the late 60s of the dispersants. Interestingly, the components that go to make up this soap, which we call dispersants, are all regulated by the Food and Drug Administration for use in and around foods or around food products. Interestingly, the dispersants corrects it 9500 doesn't have any heavy metals, so it can't bioaccumulate that. All of the components are biodegradable, so it will not bioaccumulate, and none of them have unusual toxicities. So those are the criteria we use for determining just how dangerous is this material. Now, when you disperse oil, most of the toxicity comes from the oil that has been dispersed. You put a little bit of dispersant, you get a lot of oil, and so the oil is dissolved down in the water column, and most environmental damage comes from the oil that's in the water column, not the dispersants. Again, you're accepting damage for dispersing the oil offshore to prevent greater damage when the oil comes onshore. It's a trade-off between the lesser of two evils. Better not to have to disperse it at all. If it were my choice, I would skim it, get it up, recycle it. Don't let it come ashore. But the name of the game is, if you don't have skimmers, you got to do something. We didn't have enough skimmers to clean the oil up. The oil weathered, and it was sometimes when the weather's rough, it's hard to skim. So rather than letting this thick material come ashore, it was decided to disperse it offshore.
Okay. Well, according to the video, the National Oceanic and Atmospheric Administration and the Mississippi Department of Marine Resources have declared seafood in most areas, all areas at the moment, safe to eat. What are we still looking for, and what should the public understand when they read these announcements?
Well, the first thing the public needs to understand is that seafood along the Gulf of Mexico, the northern Gulf of Mexico, has been more extensively tested than any other seafood in the entire world. By a long shot. I'm talking about massive amount of testing for our seafood. We don't know what's in the seafood harvest from many other areas, even those areas in the United States. So our seafood has undergone extensive quality testing. It is, we know, we've looked at the components from the oil in it, and we know they're not accumulating in the seafood. This is a strong statement that the seafood is safe to eat. When we go out and buy seafood that may be imported into the United States, we don't know anything about that. It has not gone any of these testing. So my statement would be that the seafood that is passed inspection along the northern Gulf is the safest in the world because it has been tested. Other seafood hasn't been tested. So I encourage everybody, and I put my money where my mouth is, and I'm eating that seafood myself. As often as I can